acho que agora foi. Bom, perdi, então. Agora apareceu. Bom, eu gostaria de agradecer a todo mundo que está aqui assistindo a gente. A gente vai dar prosseguimento na programação da 11ª edição da Semana da Física. Agora a gente vai ter uma palestra oferecida pelo nosso patrocinador ThorLabs, que é uma empresa de materiais de experimentação ótica. E então eu tenho aqui a representante deles no Brasil, a Marilde, e o Martin, que vai ser o nosso palestrante de hoje. Então eu queria agradecer muito a parceria que a ThorLabs sempre está fazendo com a Cifisc e passar a palavra para a Marilde.
Tá bom. Boa tarde a todos. Muito obrigada, Arthur, para nos dar esta oportunidade de patrocinar e de dar essa palestra também. É um grande prazer de sempre ficar perto de vocês, de trabalhar juntos com vocês nessa parceria. Hoje a gente vai, então, foi um pedido de vocês, de toda a equipe da organização, de falar um pouco sobre como a gente vai da faculdade para a indústria, o que é muito comum. Eu sou alemã, para mim é muito comum, muitos físicos vão para a indústria mesmo, e dentro da ThorLabs tem muitos físicos, muitos engenheiros. Então a gente pediu para o Martin, que é da parte do CT, então ele vai explicar, detalhar como ele chegou na indústria, saindo da faculdade, fazendo física. Can you please move to the first slide, Martin? Okay. Então, eu vou só apresentar rapidamente. Eu acho que a maioria das pessoas conhecem a ThorLabs. Então, ela foi fundada em um pouco mais de 30 anos atrás. A matriz continua sempre em New Jersey, tem a foto da matriz. A gente cresceu muito nesses 30 anos e hoje a gente tem 25 lugares, a maioria são fábricas. E cada fábrica realmente é especializada num tipo de produto. Por exemplo, as mesas óticas nossas, que pode ser que vocês já viram em muitos laboratórios, são todos feitos na ThorLabs Inglaterra. A gente está sempre crescendo em tipo de produtos, então hoje são em torno de 22 mil produtos diferentes, e o que a gente chama de Customer Inspired, e realmente a conversa, a comunicação com os nossos clientes é muito importante para nós, para saber o que vocês, como pesquisadores, precisam, e a gente vai tentar de desenvolver e de fabricar. Muitos conhecem também a ThorLabs, as Lab Snacks Box. E, então, eu não... you can go to the next slide, please, Martin. Eu não mostrei aqui a parte das fábricas, mas essa parte de vendas e de distribuição. Então, mesmo se na ThorLabs Inglaterra são feitos todas as mesas, lá eles têm também suporte para suporte técnico e suporte de vendas. E a gente, o nosso trabalho logístico também de levar para todo no mundo inteiro. Yeah, then it's perhaps easier to start switching over to English because Martin is then going to talk also. So ThorLabs Brazil, we started ThorLabs Brazil in 2012, so I'm the general manager. We're a small team here. We don't have production yet, but we're the sales and support for all of South America customers. And it's really important here also to just be close, and that's why it's really an honor to be able to present here. And I think now I can hand it over to you, Martin, please.
Thank you, Marita, for this kind introduction. So, my name is Martin. I come from Germany, and I want to talk about my own experience about moving from academia to industry. So here you see an overview of my curriculum vitae. So I did my diploma in physics at the University of Magdeburg, so in the center of Germany. After this, I moved to Leipzig to do my PhD research. And after this, I moved into the industry. So I started my work at a startup company called Oxy4, so in North Germany. And since April 2018, I'm working for a global enterprise, so for ThorLabs, especially for the OCT division, which is located in Lübeck, close to Hamburg. During my PhD period, I investigated a so-called Bose-Einstein condensate, which is a macroscopic occupation of a single coherent quantum state. So this means that all the particles involved in this condensate exhibit the same energy state. This was firstly observed in 1995 for rubium atoms at very low temperatures of 170 nanokelvin. So the scientists needed a very complex setup to achieve these low temperatures. And this was awarded by a Nobel Prize in 2001. In my case, I investigated a different model system, which are exciton polaritons in a microresonator. So here you see a sketch of my sample. So the main material is an semiconductor material. In this case, I used zinc oxide, which is sandwiched between two highly reflecting mirrors. And I used a high power laser, so to generate particles inside of this semiconductor material, which are so-called excitons or electron hole pairs. And these particles decayed after a certain lifetime and sent out another photon. But this photon was not able to leave the cavity immediately because it was sandwiched between these two mirrors and decayed again and excited a new exciton. And the whole process happened so often that in order to describe the system, you have to introduce a new model particle, which is a so-called polariton. So the polariton has excitonic, so electronic and photonic characteristics. And due to the photonic nature, the polariton exhibit a very low mass, which is 9 orders of magnitude lower compared to the mass of an atom. And this is important because the critical temperature for Bose-Einstein condensation is inversely proportional to the mass of the particles. And this means that for these very light particles, Bose-Einstein condensation is possible for much higher temperatures up to room temperature. So this model system is much more suitable for the realization of real technical devices. One main property of these polariton condensates, or of condensates in general, is that the particles have a temporal phase coherence. So you can describe these particles by a wave function, and the phase of this wave function is well correlated, and this phase correlation between different particles is preserved even after the decay of individual particles. And I have investigated this temporal phase coherence in more detail. To this end, I have set up a Michelson interferometer, which just consists of a beam splitter, two mirrors, and a detector. So I have split the emission coming out of the sample into two parts, which are reflected by each mirror and are overlaid at the detector. And with this, I could, for example, distinguish between the incoherent emission from the non-condensed polaritons, which is shown as the green curve. So in this case, I just observed the sum of intensity coming from both arms. But in contrast to this, for the coherent emission from the real polariton condensate, I observed these significant interference fringes. And how did a typical working day at the university look like? So I did a lot of experiments in an optical science lab. So in my case, I performed a so-called photoluminescence spectroscopy. So I used high power laser, which I have aligned onto the sample surface to induce particles. And these particles decayed and sent out photons again. So this means I also aligned the light coming out of the sample towards a spectrometer. So to investigate the light distributed by the different energy states or wavelengths. And these experiments could be quite complex. So I spent up to 2 weeks for the beam alignment and optimization for a single experiment. I also gained some experience with MATLAB to perform an automated analysis of large experimental data sets or to perform numerical simulations, which I could then compare with my experimental results. I also had a close collaboration with a theoretical physicist, so I needed to perform interdisciplinary teamwork. I also presented my results for large audience in seminars and national and international conferences. And most of these either oral talks or poster presentations were held in English. I also gained some experience with teaching, so either in giving exercise seminars or lab courses for students. I also had 2 research stays at a university in Spain for 1.5 weeks each, where I gained some experience in international teamwork. And a very joyful part of my PhD period were several business trips to national and international conferences and a PhD summer school. So after I finished my PhD, I moved into the industry and started my work at a startup company, which is called Oxy4. The purpose of this company was to develop a wearable sensor to monitor the training status of athletes. So on the right-hand side, you can see the design of our prototype sensor. And on the left-hand side, you see a sketch which shows the working principle. So the sensor was attached to the skin and consists of a multi-LED module and a detector. So the light from these LEDs penetrates through the skin down to these capillary vessels in the muscle tissue, got backscattered and detected by the detector. We used 6 different LEDs with different emission wavelengths, which could be switched on and off one after another. With this, we could achieve 50 full sequences per second. And we could detect the backscattered emission for each LED individually. So with this, we could measure the relative absorption coefficient at different wavelengths. And this is important because we wanted to calculate the oxygenation level in the muscle tissue. And the oxygenation level is given by the percentage of the red blood cells which carries an oxygen molecule. And here we could use the fact that the absorption curve of the hemoglobin, so the pigment of the red blood cells, differs depending on the fact if they are oxygenated, so if they are carrying an oxygen molecule, or if they are deoxygenated, so if they do not carry an oxygen molecule. So here you see the different absorption curves for the oxygenated and the deoxygenated hemoglobin. And by measuring the relative absorption at these 6 different wavelengths, we could calculate the ratio between these 2 curves. And with this, we could measure the percentage of the red blood cells that carries an oxygen molecule. So this parameter is called the SMO2, so oxygenation level in the muscle. And why it is important to measure this? It's important because the oxygenation level decreases during anaerobic activities, such as weightlifting or intense endurance sport. So this is connected to the lactate level in the blood. So as soon as the lactate level increases, the oxygenation level decreases. So the sensor should provide an alternative approach for example, spiroergometry, where the athletes wear a mask and you measure the oxygenation level in the respiratory gas. And another approach is lactate testing, so where you apply a ramp test to the athletes. So you increase the load step by step, and after each step, you extract a blood sample and measure the lactate level in the blood. Both methods are well established and well understood, but they require lab conditions and technical stuff, so a lot of effort to perform these tests. So the idea of our sensor is that you can monitor the oxygenation level and other parameters in real time during the standard training without any additional effort. So you can monitor your training status in real time or to discuss the results afterwards with the trainer or with a physiologist. So my task for the startup company was to perform exercises, to generate some data with our prototype sensor on different machines. The major part of my job was to develop an algorithm with MATLAB to extract these parameters, such as this oxygenation level. And then my colleague had to transform and implement this algorithm into the sensor's firmware so that also the sensor is able to calculate these parameters in real time. I also developed a calibration routine for different sensors. I performed literature research to find a good algorithm and optimize it. I collaborated with partners from a technical college, and I also presented our prototype sensor at an international trade show located in Germany. So what are the required skills for this specific job? So I could apply my programming skills with MATLAB, which I gained during my PhD period. I also had to do some interdisciplinary teamwork with my colleagues, so with a product designer, electrical engineer, and a firmware programmer, and also with these project partners from the college. I also did project management, so I had to prioritize my tasks and achieve milestones until a certain deadline. Then I needed some stamina and frustration tolerance because the tasks were rather long-term tasks and not each approach was really successful from the beginning. And I also need to apply my English skills because we collaborated with a non-German project partner, and also a lot of visitors at the trade show were non-native German speakers. So after this, I moved to ThorLabs, so to an international company. And I started at the Lübeck office, who was responsible for the developing and the manufacturing of optical coherence tomography systems. These OCT systems are distributed worldwide, and we now have a team with roughly about 35 employees. What is optical coherence tomography? So it's an imaging technique to look really inside of different kind of tissues. In general, OCT is based on white light interferometry. So we are using a broadband light source and focus the beam onto the sample surface. So the light is then penetrates inside of the sample and is backscattered at different structures. And then we guide the light through a Michelson interferometer to measure the travel times of photons. On the right-hand side, you see two examples of cross-sectional OCT images. So the Z-axis denotes the depth axis. So in this case, we look inside of the sample, and the X-axis shows the lateral scan direction. So here we see the cross-section image of the fingertip. So we can see the epidermis and the dermis layer, and also some thread ducts. And here we see a cross-sectional image of a plastic film. So you can see different layers, and you can also use the OCT image to measure the layer thickness with high accuracy at different positions. Here I want to present a typical application example. So you can OCT, for example, for dental applications, so for imaging human tooth. And this can be used to detect carious lesions. So in general, with OCT, you get structural information from the most exterior layers, which is the enamel and the dentine layer. So the enamel is the hard mineralized surface of the teeth, and the dentine is the underlying layer, which is slightly softer, sensitive, and supports the formation of the enamel layer. So on the right-hand side, you see the video camera image, which is also provided with our ThorLabs OCT systems. And the red arrow highlights the scan of the OCT beam. On the bottom, you see the OCT cross-sectional image. So also along the Z-axis, we can look inside of the tooth, and the X-axis shows the scan direction of the OCT beam. So here you have to know that the enamel and the dentine layer shows a highly ordered structure. But in case of caries, this causes a demineralization of both layers and a structural disorder. And in the OCT image, this structural disorder can be observed since you see a highly scattering contrast, which is here marked by the yellow rectangle. So here from the OCT image, you can clearly differ between the disordered structure caused by caries in contrast to the healthy tissue and on the left and right hand side of this image. So in this case, OCT can be used to detect carious lesion in an early stage. So you can treat these lesions before it becomes to irreversible damages. So what are my typical tasks at my current position at ThorLabs? So I am a member of the OCT applications team, which is also located in Lübeck. So, and the main responsibilities of our team is that we are usually the first point of contact for new and existing customers. So we perform test measurements and provide reports for customers. We also provide technical support for customers who already have an OCT system. We present our system at trade shows and conferences. And we also perform demos and installation of OCT system. So either we are visiting the customers or we perform this remotely. Before the COVID-19 pandemic, I also had frequent business travels, so about 5 to 6 trips a year. One of those could be intercontinental. And due to the fact that all ThorLabs systems are developed and manufactured in Lübeck, but distributed all over the world, we also deal with customers all over the world. What are my required skills for this specific position? So I need the ability to gain a profound understanding of these complex technical systems so that I can also explain these technical details to the customers. I also need these my English skills because 80 to 90% of the customer communication is in English. Yeah, I need to do a lot of teamwork, so I discuss with our engineers with different technical backgrounds, and also with the production and sales staff on a daily basis. I need communication skills for the discussions with the customers. So I have to explain technically relevant system parameters and our test results to a large variety of different customers. So we discuss with OCT experts who can be the opinion leader in their fields or have developed their own systems. But we also discuss with operators who just want to use the OCT system as a tool and only have a limited technical background. And I also do literature research to get an overview of the current OCT research, the system developments, and the situation at the competitors. And yeah, with this, I want to summarize my task and my talk and want to compare the main difference between these different stations from my point of view. So during the academic research at the university, I had a detailed research on a single project for several years. I could rather work independently, so I could design and perform my experiments on my own, but then just discuss the results with my supervisor. I could investigate a single problem from different perspectives. But regarding the working conditions, so in Germany, you usually have fixed term contracts. So this means after the PhD, you can work as a postdoc for several years. But after this, you either become a professor or you have to look for a position in the industry. During my job at a startup company, I had a quite high responsibility. So because I was a major part of the whole team, I had a significant impact on the product properties and the strategy of the whole company. So our CEO asked us about our opinion from time to time. We had a family working atmosphere because me and my colleagues, we shared the same vision and really worked together very closely. We also had some high workload during specific periods, so especially prior to a trade show, where we also had to perform a night shift or work on the weekend. And in general, working for a startup company is some kind of an adventure. So there's a risk of failure. So like it was in my case, so this company does not exist anymore. But on the other side, you have the quite good opportunity to get a high-level position at an innovative and rising company. And since the last 3.5 years, I'm working for a worldwide enterprise at ThorLabs. So the whole company provides really a huge basement of knowledge. So this means that for almost each problem, you can ask an expert and you do not have to solve each problem on your own. You have a well-structured workflow and well-defined process chain. You also have more specialized activities which ideally fit to your own personal skills. You have a good option to gain experience as different entities at different countries. And compared to the startup company, you have a razor safe job. And with this, I want to thank you for your attention, and I am happy to answer your questions.
Muito obrigado, Martin, pela sua apresentação. Foi muito enriquecedor. A gente vê uma perspectiva de carreira diferente do que a gente tem em mente, geralmente para física. E foi muito bom ver a comparação, porque você já teve experiência em 3, tipo academia, startup e uma empresa mais, não por dizer séria, mas mais tradicional. Então, é isso. A gente, por enquanto, não tem nenhuma pergunta no chat. É só o pessoal está agradecendo muito pela sua apresentação.
Perhaps I just translate, just so thanking you, Martin. Arthur was saying for the presentation, showing the different, like 3 different activities that you did so far in at the university, in the startup, and at ThorLabs now, so different areas. To now, apparently there's no specific question. Shall we still wait, or a gente vai esperar?
Eu vou...
Senão eu tenho uma dúvida. I would like to know, Martin, so do you think it was really very important for you to have the experience of the startup before coming to ThorLabs? Or would it have been good also to go directly to ThorLabs? Do you think you would see structures differently in ThorLabs because you have the experience of the startup?
So in general, I would say it would also be good to directly go to the big company, to ThorLabs after the work at the university. But of course, I don't want to miss this experience which I got during my work at the startup. So at my current point of view, I find it very interesting, so that I can really compare the different working conditions between both companies. But let's say that also depends on the personality. So this means that if you already know that your own personality better fits to the conditions of a larger company, then it would also be no problem to directly start or directly apply for jobs at a larger company.
Na verdade, a gente teve sim pergunta aqui no chat que eu não tinha visto. O Matheus Fernandes, ele agradeceu a apresentação do Dr. Martin e ele perguntou: Did you know you were going to the industry before your PhD?
No, so this was really a decision which I have done during the PhD. So I liked the work in the lab a lot. But as I mentioned, I also needed a lot of frustration tolerance. So let's say I did my PhD for 5 years, and I also had, let's say, a lot of approaches which were not successful, and also, for example, worked on a specific project for over 1 year, which then was not really successful, and I could not use it at all for my PhD thesis. So which was fine for this limited period of time, but with this, I recognized that I would prefer to have well-defined tasks and let's say see some kind of results at the end of the day, or at least at the end of the week, which is now the case at my current position.
E, Maria, você podia trazer para mim? Eu tenho uma pergunta também. Eu queria saber qual a opinião dele sobre perspectiva de um físico brasileiro conseguir entrar na indústria no exterior, porque a gente sabe que aqui no Brasil é meio complicado ainda. Mas para ver se esse campo no exterior está sendo suprido pelos pesquisadores dos próprios países ou se é um campo que ainda conseguiria abranger a gente daqui.
So Martin, Arthur would like to know what you think. So for physicists who have studied in Brazil and have done their degree here, do you think there would be a good chance for them in outside of Brazil to work in industry? So for example, in Germany, would you say that the German market is saturated by German physicists, or do you see openings possible for people coming like really with a degree from, for example, from Brazil?
Mm. I would think that there would also be very good opportunities from physicists outside from Germany, so also from Brazil. So I have the feeling that at these positions where you work as a physicist, they are quite could be quite international positions, like in our let's say now in our company, so in the OCT division. We deal with customers worldwide, so this would be no disadvantage at all to also have some experience from a different country than Germany. In general, I think that the business is really open-minded to work with people outside from Germany.
Yeah, I would also add that, so what Martin is doing is one career as a physicist, né? So really it's more the tech support, a little bit into development, but I think, I don't know if you know about other colleagues of yours who did the PhD together with you, Martin, what they would typically do if they go to industry. They do more engineering, product design, project management. I think you talked about a little bit about all of these.
What I heard about my colleagues are really very different ways after the PhD. So some of them really still worked at the same group as a postdoc. And one of them, I guess, still have the vision to become a professor and stay at the university. But I guess other colleagues just use it as an additional period to, let's say, stay at the university before then they apply for a position in the industry. A lot of physicists, I would say, work in the product research and product development. So this is also the case for our own company here in Lübeck. So we also have several physicists who are working in the engineering team, so which want to improve the OCT systems or develop new system configurations. But you can, let's say, also let's say work more or less theoretical. So for example, for insurance companies to perform these internal calculations and risk management, or to start in an go into the company as a project manager, so to not really perform some experiments on your own, but to really already lead a small group of other people for product development, for example.
A gente teve outra pergunta aqui no chat da live, do Lucas Konaka. How exactly was your transition from academia to industry? Did you go through a lot of interviews, and how long did it take for you to get a job in the industry?
Okay. In my case, let's say the whole period of job interviews and applications was about 3 months. I mean, I already worked at the university quite long, so for 5 years. And at the end of this period, my contract was already cancelled. So this means that the last 3 months I was officially without a position, so I had to apply for several jobs. And but I only had 3 job interviews with 3 different companies before I got this job offer from the startup company. And this was the same after I moved from the startup to ThorLabs. So also in this case, I applied at different companies, but in this case, I only had 2 job interviews at different countries, so different companies. So just another company before I got the job offer at ThorLabs.
Bom, beleza. Eu acho que a gente não tá com mais nenhuma pergunta aqui no chat do YouTube. E como já tá dando o nosso tempo, eu queria perguntar a Marilde se você quer fazer mais alguma fala, se o Martin também quer.
So Martin, we're at the end of the time and there are no more questions. Is there anything you would like to add or to summarize?
First of all, I want to thank you to get this opportunity to talk about my own experiments, and I hope that some of these statements will help you to find your own way and make your decisions. But in the end, let's say your own way also have to fit to your personality.
Yeah, I think I would completely agree if I can say that from my point of view. So I think in Germany it's very usual that you do go to university, but you not with the goal of becoming a professor necessarily. And really, I think what Martin pointed out is it's good if you. I think studying is a way to learn about your strengths also, about, like Martin was saying, his 5 years PhD, there he really saw what he liked during that time where he had to work already much more independent, I imagine. So it's about finding what you like doing, what your strengths are, and definitely to your question, Arthur, are there positions out there for Brazilian physicists? I would say yes. It really depends on being so. It may be completely different from what you did in your studies. But it depends on whether that's what you want to do. So I think it's really exciting. I think it's a great idea that you asked us to present about this, because for ThorLabs, definitely worldwide, we have a lot of engineers, we have a lot of physicists, chemists, chemistry background. It's finding the right team that you would want to work with. I think it's great. I really have to say to you, as the team who organized this event, also thank you very much, because you organized very well, very professional, very communicative, which is super important. So congratulations and best of luck and best of success for the whole session.
Muito obrigado, Marilde. A gente que agradece. E, na verdade, antes só da gente encerrar, apareceu mais uma pergunta aqui no chat do Gabriel. Ele perguntou, Martin, do you think that the transition from academia to industry could be done in a short period, for example, after a master's degree instead of a PhD, and at least in the field of photonics, if this is possible?
I can only talk about, let's say, the situation in Germany. So in this case, it is really possible. So it's not necessary to do the PhD before you go into the industry. I mean, the decision if you do the PhD or not rather depends on your, let's say, personality. So it does not usually mean that you have a better opportunity to get a job in the industry, but it just rather depends, let's say, if you want to stay at the university and gain further experience with these fundamental research, or if you just want to do some hands-on task and really do some things which are, let's say, more practicable. So, but there are still a lot of good positions for people after the master degree.
Bom, eu acho que agora é a última chance de alguém fazer alguma pergunta. Se não mandar no chat, vai perder a chance para sempre. Bom, como não teve nenhuma, agora sim, eu acho que a gente pode encerrar. Eu queria agradecer muito a ThorLabs por ter demonstrado esse interesse em ser parceira da gente. Eu queria agradecer muito a prontidão que vocês estavam. Também sempre que a gente tinha alguma coisa para falar, a Marilde já estava respondendo quase que na hora. Foi muito bom fazer essa parceria com vocês e foi um tema muito pertinente e o Martin foi uma pessoa muito boa para vir falar um pouquinho sobre essa perspectiva que é um pouco diferente do que tradicionalmente a gente tem aqui no Brasil, como tipo, você pensar, você físico é para ficar na academia. Então foi legal trazer essa outra perspectiva. Então eu queria agradecer muito a ThorLabs, a Marilde e o Martin por terem topado vir aqui falar um pouquinho com a gente. Queria agradecer também todo mundo que está assistindo e lembrar que mais tarde, às 16 horas, a gente vai ter uma próxima palestra que é sobre missões especiais para estudo de astropartículas ultraenergéticas com a professora Ângela Olinto. Então, a gente espera ver vocês de novo daqui a pouco. Tchau, tchau. Eu vou estar encerrando aqui a live.
Muito obrigada. Tchau. So that's the end of the session.
Okay, goodbye.
Bye.